Hello, my name is Ali Dastrep, and in this series of videos, we want to build on what we had as a Delta development exercise and add more features to that exercise and compare the results a bit. The first thing that I want to do is that I want to build on the original Delta development exercise that we had to add a cohesive sediment fraction to the model to see the effect of cohesive sediment in Delta development, add sediment underlayers to the model to be able to visualize how the different sediment fractions behave inside the bed, to make a 3D model for the case, and eventually add salinity to the model to see the effect of salinity on Delta development. But to start, I want to go back and use the model that we have developed before called Delta 0 and make a copy of that input files or that model and make a shorter version of the same simulation. Because I want to run a few simulations and I don't want this to take a long time, I will make a shorter time for that simulation. So I will open my total commander. I had a Delta 0 directory from before. I make a new directory called Delta 01, and then I go to Delta 0 and copy all the files that I had there into this new directory. And now I have a Delta 0 directory with all the new files. Then what I want to do is to select also my working directory. I go to this Delta 01, which is my new directory. I select this folder, I open the input file, I go open my flow input file here and then look at the time frame, and instead of 2 months I will make it only a 10-day simulation. Because our morphological factor was 100, having 10 days of simulation, it means that morphologically our simulation time is 1000 days. Now I can save the simulation, save my file, and close it and start the simulation. So I'm running the simulation, which takes on my computer only about 13 minutes to have a base model and compare the result of this model with the result of next models that we will make to see the effect of the changes that we are making. That was the model number 01. Now I want to continue with model number 2. Again, I want to start from a previous model. This time my previous model is Delta 01, and I want to add a cohesive sediment fraction to the model and also add the underlayers to the model. I go back to my total commander now. I go up. I make another directory here called Delta 02. And then this time I want to copy the input files from Delta 1 to this Delta 2. And the easiest way to only copy the input files and not the output files from a previous model is to sort all the files by days, by dates, and then everything older than run ID is usually all the input files that I need. So I will copy all these into the directory Delta 02. But now I can also come here and change my directory, my working directory to Delta 02. Select this. Now I want to add cohesive sediment to this. So I go to flow input. I open the flow input of this Delta 2. I go to processes. I have the sediment here. I click on edit. And I say, okay, now I want to add a cohesive sediment called sediment mod to the model. Click add. And now you can see that we have this in the model. The next thing that I need to do here is to go to the physical parameters for this new sediment. I go to physical parameter, I go to the sediment, and here you can see that I had the sediment sand with the initial thickness of 5 meters of available sediment. I will make this 4, and then I will go to the sediment mod. I click on next 2 times. I see that the default initial sediment layer thickness at bed for sediment mud is only 5 centimeter, but I want to make it 1 meter. So now I have about 20% of my material, my bed material of cohesive sediment and 80% on non-cohesive sediment. It is 1 meter of cohesive sediment and 4 meter of non-cohesive sediment. So in total it's still 5 meter, but the mixture has changed 20%, 80% between cohesive sediment and non-cohesive sediment. So now I also have mud coming into my model. If you remember from our previous lectures and videos, if we go to Morphology tab and if we have this equilibrium sand concentration profile on, it means that for sediments that are non-cohesive, so practically sands, model calculates the equilibrium concentration at the boundaries and bring either sediment in or take the sediment out based on the flow direction. But that's not the case for mud. So for mud, we actually need to go to the boundaries and tell the model how much cohesive sediments we want to bring to the model. In this case, for the river, I click on the Edit Transport and I say that, okay, for sediment sand, it doesn't matter, but I will keep it at 0. But for sediment mud, I want to bring in the concentration of 0.2 kilogram per cubic meter of cohesive sediment from the river into my model. So I add them here. But then if I go to the north, which is the north boundary, which is my sea boundary, one of my sea boundaries, and I click on the Edit Transport condition, for sediment mud, I will make it 0 because I don't want to bring in any mud sediment from any cohesive sediment from the sea boundaries. The same thing for the boundary west and the same thing for the boundary south. Yeah. So this is also all the boundaries that I have edited. It's also explained in this PDF that you also have it. Now we want to also add underlayers to this model. But just to make sure that I don't lose anything, I come here and call Save All, and everything is now saved correctly. For this, adding the underlayer to our model, we should follow what we also have seen in the previous videos when we introduced the underlayers. But just to remind you, we need to turn on a keyword called underlayer equal to 2 and turn on the underlayer, give maximum number of underlayers, define the thickness of transport layer, and define the thickness of bookkeeping layers. And to do that, I simply go and copy it from the file that I had before. So I go to help directory here, look at this. These are the keywords that I wanted to copy. I copy them. I come to directory delta 2, find the more file, open it, and add these files to the end of it. And then I save this file, and now my model is ready to run. I again check here. I have saved everything, so I'm okay. I can close this and say, okay, start. And now I am running the second model as well. You can see that this model now takes about 2 times more than the previous model. The reason is that we have added a cohesive sediment fraction to the model. So sediment calculations is happening 2 times now. And also we have added the underlayers. So understandably, the model takes longer. I will also let this run. Now, before going to exercise 3 and 4, I will wait to get the result of these 2 models